Okay, so hello everybody. Here I'm representing ETSI MEC as a chairman of this group, but also I have to mention that part of the work, I'm delighted to present some updates from a special task force. It's a work done not by myself, so the glory is up to them. Those guys are doing the hard work and presenting their results and achievements on their behalf. There are also some guys representing this special task force called Edge Native Connector in the booth area, and there is Jan Garcia representing there and giving some demos. So this is part of the work, including, of course, the results from the standardization body, which I'm happy to chair, and this task force, which is also implementing in software some nice things related to MEC. Okay, so and then, of course, an overview about MEC very quickly, and go immediately also on the MEC Sandbox that is there as a tool for developers since many years, I will say, in phase 3, MEC phase 3, and now we are also evolving. The current special task force is also implementing also in collaboration with OpenCapif, so I'm glad to see that we are collaborating practically, and you can see finally not only specifications and things done on paper in the PDF file, but also in the software. And this is a concrete proof that things are implemented. So very quickly, of course, what is MEC about? It's multi-access edge computing, is an ISG, industry specification group, and essentially standardizing edge computing in a multi-access fashion, so access is not agnostic, but also when it comes to deployment in 5G, and this is of course fully compliant with 3GPP, but you can also deploy MEC on a Wi-Fi network or a fixed network, why not also on satellite. So really access agnostic technology based on virtualization, and then reusing as much as possible terminology from ETSI NFV. If you are familiar with NFV, and you can look at MEC architecture and ETSI MEC specifications, you can recognize some names. Sometimes we don't need to reinvent the wheel. In other cases, we specify more and detail some more, let's say, tailored functions which are related to MEC by reusing and specializing some functionalities in the MEC architecture. The group is growing a lot. I'm having the pleasure to see that when I was starting in 2021 being a chair, it was like 120 members and participants. Now we are over 180. It's really a sign that I believe edge computing market is growing and becoming more mature. And this is a definition of what MEC is about. It's very much designed to be precise and specific. MEC offers to application developers and content providers cloud computing capabilities and IT service environment at the edge of the network. Let me emphasize at the edge of the network, not necessarily at the edge of the mobile network or the edge of the radio access network, core network is a general concept, and also not limited to cellular. We provide what is ETSI MEC customer is more application developer and content provider, okay? So the core business, if you allow me the term, of this standard group is also to produce APIs to be used by application developers, and also not just only cloud computing at the edge, but also these added value functionalities that can be used and consumed. So well, this is already described. MEC is also reusing NFV definitions and also aligning with 3GPP, but also addressing the needs of multiple use cases and verticals. I'm glad we mentioned a transformation function because I have some view from ETSI MEC here. So, but I have also to mention that ETSI MEC is, of course, a standardization group, but there are also other activities which are not traditional standardization activities, which are falling into the code working group in MEC. and are related to many deployment and ecosystem engagement activities. And this is the list mentioning open API representation under the ETSI Forge site, testing and conformance with many task forces across the years, a MEC ecosystem wiki with some examples of implementation from the ecosystem, proof of concepts. We have a lot of proof of concept there implemented and showcased in many events. MDT, meaning MEC deployment trials with operators and also multiple operators, talking about federation. And the MEC Sandbox, as I said. Collaborations, we have collaborations with open source communities, industry groups, also Camara is one of them. We organized a lot of hackathons since, I believe, 2018. And plug test events for interoperability, and also publishing a series of podcasts to explain some tricky parts of the specs, very much tailored to the need of a developer to facilitate the adoption. So you see a lot of work has been done since the creation of the group in 2015. Any phase lasting 3 years was a milestone, setting the scene, implementing, defining what is infrastructure as a service, platform as a service. The first APIs, we expanded from mobile edge computing to multi-access edge computing, adding the support for Wi-Fi and fixed access networks, and many more APIs, also collaborating with the verticals, 5G AA, very fruitful collaboration, and we expanded, we're studying MEC application slices, MEC deployments, starting to study in phase 3 security aspects, and expanding also on federation. And now we are definitely entered in the phase 4, which is also continuing the work on the federation, but also adding new key requirements and working hardly on normative work for security, and also studying abstracted network APIs for industry. This is a study led by Nokia, which is also very interesting because we want also to understand from vertical market segments what does mean to implement a sort of transformation function to abstract from network APIs to service APIs. And in our view, the answer is, of course, listening at the specific needs from market segments. And then, for example, I have a personal experience on automotive. I worked a lot since 2017 in a 5G Automotive Association. You have really to listen at the problems that they have in this specific market to understand how to translate very detailed information from network APIs to something which is consumable from this kind of market. And this is an important study that needs to be done, depending on the different verticals. And many other activities, including MEC Sandbox and Edge Native Connector, as I mentioned. So we are heading to 6G. We're not claiming that we know what 6G will be. Of course, nobody can have the crystal ball and predict the future. But of course, on the other hand, being careful on that, we have to be ambitious and study and prepare to what could be pertinent to that phase, because in phase 4 this will last at the end of 2026, so it's perfectly appropriate to think about the topics that could be relevant and pertinent for MEC to be supported, to support 6G, considering also that MEC is access agnostic, so we are not going to define the radio access technique. So, and then here, this is just an extract from term of reference in phase 4, and we are going to work on multi-domain, multi-tenancy slicing, MEC support for application slicing, more cloud-native communication system support, edge native design for application developers, security and privacy I mentioned. We continue working on federation as I mentioned, and also I see a lot of increasing attention on the software development, open source, possibly continuing working with the hackathons and other initiatives in collaboration with the other open source communities. And so, as I said, we have many vertical industries to serve. We are not the experts on the different vertical markets. We want to listen at them. we started in 2022 with the Edge Exposure Day, and we wanted to instantiate specific events to listen to their needs, called Edge Discovery Events. We organized the first event on drones, with more than 70 people registered, very skilled in this market, and 6 keynote speakers and 1 demo, where we wanted to really understand their pain points, how they see edge computing and a value for their market. Same story for spatial computing and gaming, and other events organized especially to understand their needs. All the material, by the way, including the presentation from the speakers, is available publicly to everybody. So everything is open on that. And so we are planning also other events for other vertical markets. So you can have a look to the MEC Wiki and stay tuned for discovering what can be the next event we are going to organize soon. So now, very importantly, the MEC Sandbox, it's a huge endeavor. I mentioned that several task forces have been established because we had in mind an important point. Developers, they want to understand how to use MEC, and of course the infrastructure, as we see a lot of initiatives in the software communities and projects, is very complex, right, to manage. So starting from simple things, MEC Sandbox is a tool to let you understand and play with the APIs. So, and we wanted to make this more serious gradually, and this is actually a first example of a, let's say, simplified MEC platform, fully compliant with the specifications, and MEC 11 in particular for the service exposure for the Edge platform, and also in synergy with OpenCAPIF, and also Camara and OPAG, taking in consideration the harmonized architecture between ETSI MEC and 3GPP SA6 Edge app. And I will mention that in a minute. So you can see here public website. If you have a GitHub account, you go there, you log in, and you can see this environment for free. A MEC server will be instantiated for you, dedicated for you, thanks to ETSI services. And of course, you can play with many network access technologies, 4G, 5G, Wi-Fi, and you have different use cases. In this case, we have a V2X. There is an API console with a graphical user interface. Everything can be tried out to understand how this is working, of course, in a simulated environment, but still what matters for the application developer is just abstract from this complexity, understand how they consume the APIs, right? So, and then we did also more. We wanted to make it, let's say, integrated with CAPIF. Now we have, after, I would say, more than 2 years of efforts, as a joint effort with other 3GPP delegates from many companies, we aligned 3GPP release 18 with the ETSI MEC phase 3 specifications. This was a huge endeavor. Now I can say that we are also progressing with the TR on CAPIF guidelines to clarify how ETSI MEC can be deployed in a 3GPP network and CAPIF can be used. We created a MEC profile for CAPIF and also implemented here, and you will see also the demo in the booth area. So it's there, it's up and running, and we have also implemented some use cases on V2X API and predicted QoS for this automotive use case. And we have also federation enablement APIs, which are related to the multi-operator environments, which are very much important also for Camara, for Open GSMA Open Gateway initiatives. So it's something that is a serious plan. We want to really to make it useful for the developers. And also the other APIs are mentioned because you can consume different APIs compliant with the specifications that we have published across the years. So an example here, I mentioned the automotive. Very quickly, this is also defined and described in the MEC 30 specification. You may have simply in the case where you have maybe a car and then maybe a situation of mobility, you want really to understand what is happening for the network conditions, and then you may have some prediction functions that help you to understand the predicted QoS. So the specification is giving you some means on V2X information event notification to support application to be proactive on that, take some action. What happens if I know in advance how there will be a degradation of the QoS, or if the QoS quality of service will improve again back to this initial situation? If I know this information in advance, I can take some countermeasure, and my application can be proactive and, I don't know, adapt the bit rate of a video stream to maintain the connectivity and the quality perceived by the user, and so on and so forth. Okay? So, few examples. I will not go into details. But of course I will be happy to provide, to be myself a gateway to for the special task force if you have any questions related to how to use and exploit as the best possible way this MEC Sandbox. But really you can have your own client and carry with some messages, HTTP commands, get, post, all the RESTful APIs which are defined in the standard. Get, of course, once you have instantiated a server, you get a response and see all the information that is available. In this case, unicast provisioning info according to the specs. And this is also another example of a post for the predicted QoS I mentioned before. So you can see examples implemented in the MEC Sandbox. Now, the evolution of the Edge Native Connector. As I said, the ambition is to make it also integrated with OpenCAPIF. You can see here the public page for the special task forces. This is let's say a project with milestones almost completed, but and we achieved a lot of nice things, providing API-driven sandbox for application developer, the support for CAPIF APIs, for platform interoperability, and support for MEC Federation APIs to enable multi-platform and multi-host interoperability. So here the link of the intermediate delivery. Once this task force will be ended, all the platform will be available in the main web page, try-mec.etsi.org, but still you can already consult. This is publicly available, this intermediate delivery, so it's already there if you want to use it. And there is also a nice demo you can see below a link. I believe it will be quite interesting because you can really understand in practice what does mean having the possibility to carry the list of services available for the application to be consumed. And this can be done also an alternative to the graphical user interface. You can do also in the MEC Sandbox with the GUI, or without that in the command line. And then this is another alternative that is of course possible now. And yeah, this is again an example of the implementation that actually is also including the initial authentication setup before consuming the actual API. And giving you the example of the get for a specific scenario selected, in this case 4G, 5G, macro, V2X. And as I mentioned, there is a white paper published back to, I believe, 2021, clarifying how the standard in 3GPP SA6 Edge Up is aligned, that can be seen harmonized with ETSI MEC. Essentially, there was a conclusion in release 17, but also more consolidated in release 18, that you can consider MEC applications and Edge application servers more or less as the same kind of entity, and can be seen also as the API invoker for a platform, which can be seen a flavor of EES or MEC platform. They can coexist in a single implementation, actually. But we want to make clear that from a standard point of view, we should leave the market free to decide if they want to have a separate kind of implementation or joint co-located single instance implementation of the platform. So from a standard point of view, there is no, let's say, difference in principle in terms of functional blocks. With this in mind, of course, there is a possible degree of freedom. You can also implement MEC in the network operator premises, but can be also in the edge computing service provider domain outside the 3GPP domain. So this is also a degree of freedom that offers more flexibility. And well, okay, here there's a description of the MEC profile for CAPIF APIs. I will not go into details, but don't worry, all the material will be available. And also this is extract from the standard from 3GPP aligned with the ETSI MEC on this alignment between the APIs in MEC and CAPIF, and also an example of a diagram for exchanging the information when it comes to using the MEC profile for CAPIF. Yeah, just as other examples on the discovery, published service APIs via CAPIF. And okay, just 1 second. And also to give a view, of course this is a deployment option, but just to put all the things together, how the standards is related to an implementation, of course it's up to the adoption. But in principle, the ETSI MEC standard can be seen also complementary to the other initiatives. Like mentioning here, Kalmar architecture. On the below part, you have the Edge platform in the flavor of EES or MEC platform, but in any case, it's a platform. And then you have potentially a transformation function, which can be or not transparent if you need any abstraction, okay? And then, you, of course, you have CAPIF core function and CAPIF for exposure gateway functionality. And then, of course, the application developer can be on top, consuming APIs as an API invoker. Okay? This is just an example. You can see a white paper describing more in detail this concept. And then moving forward, of course, more federation APIs and enabling integration with other 5G simulators, interestingly, of this Edge Native Connector, finalization of the code base, all the tasks, importing and publication in the main page, as I said, in try-mec.etsi.org. And with that, I concluded my presentation. Thank you.